Hello students, welcome to today's tutorial on product resolution techniques, lecture 6. In today's lecture, we'll study about downstream processing of various products. So downstream processing of products is a major concern. So finally, after this downstream processing, your product should be marketable quality. So that is the main concern. So today we'll be studying the downstream processing of two important products, that is citric acid and vitamin B12. Okay, these two products we'll study in detail. Apart from these two products, there are various other products whose downstream processing will be studied. So even insulin and even ethanol downstream processing steps have been studied. So that has been already dealt in the previous lectures. But now we will study two important products apart from ethanol and penicillin that we have seen, that is citric acid and vitamin B12. Coming to downstream processing of citric acid, So before we start, we should know a little bit about citric acid. So citric acid is a weak organic acid and it is used as a natural preservative. So it is present naturally in fruits like citrus fruits, okay, but it is present in small quantity. But now when you think of marketing this as a product, citric acid, you will have to produce it in bulk. So to produce this in bulk, you can try to produce or exploit organisms, and among the organisms, Aspergillus niger is one organism, a fungus, which is widely exploited for production of citric acid. Apart from this, even Candida and other species can be used, but there is a problem with yeast. That is, they produce a lot of byproducts. So instead of producing citric acid, they produce isocitric acid. So which is a problem. So we don't want isocitric acid production, we want to produce citric acid. So to avoid that, you can try to use Aspergillus niger and we can try to improve the strain. So there are various techniques by which you can try to improve the strain by either changing the substrate in which the organism is growing, either by introducing certain, avoiding the presence of certain ions or trace elements like manganese, etc. So that helps in synthesis of citric acid. Okay, so basically glucose is converted to pyruvate in the cytoplasm and pyruvate is converted to acetyl-CoA and oxaloacetate in the mitochondria, which these are the precursors for citric acid production or citrate production by TCA cycle or Krebs cycle. So this is simply to show you how it works. So glucose to pyruvate, pyruvate to acetyl-CoA and oxaloacetate. So these two compounds combine together to form citrate. Okay, so this citrate we require. Okay, so now what happens actually within the Krebs cycle, this happens within the organism. Okay, so now once citrate is produced, it further converts to isocitrate. So in most of the yeast, this pathway is further continuing, and that is how it leads to byproducts, and we don't want this byproducts. So that is why in Aspergillus niger, the mutant strain, what they do is they block this pathway. So this achotinase, conversion of citrate to isocitrate, that pathway is blocked. So once that is blocked, the further continuation of the cycle will not happen and citrate will accumulate within the organism, which can be exploited later and extracted within the systems. So that is how, trying to block these certain pathways, we can try to accumulate citrate within the organisms, and organisms are exploited because we know the multiplication rate or the doubling time is very fast, because of which you can try to produce this citrate in large quantity. So that is why we are trying to exploit organisms for production of these products like citric acid. Okay, so studying a little bit about various parameters which are required. One is the carbon source. So organism requires carbon source, nitrogen source and other sources for its growth. So considering the carbon source, sugar such as sucrose, maltose, glucose, those can be utilized because they can be catabolized easily by the fungus. And apart from that, various other products like beet and molasses are also used in the industry. Okay, and if you are trying to use glucose, then you have to be very careful. A concentration about 100 grams per liter to 200 grams per liter will be okay. You can see there concentration of glucose source should be very high, of about 100 to 200. So that once you give a proper sugar source, the optimum yield can be achieved within the system. So trace elements, as I told you, manganese, iron and zinc. So these are problematic. So even very small concentration of 2 microgram per liter will reduce the accumulation of citric acid by 20%. You can see 2 microgram per liter. Even such small concentration can reduce the accumulation by 20%. So you have to be very, very careful. It should not have any metals like these, so which can have an impact on the production of citric acid. Apart from that, pH is one major concern, and acidic pH or low pH is very good for accumulation of the system, that is below 7, and below 2 if it is very good. And as you know, citric acid is acidic in nature. Once it starts producing, the pH of the system starts to fall, so that is naturally attaining the lower pH conditions, which is suitable for the growth of this organism. Apart from pH, nitrogen source. As I told you, organisms require nitrogen for their source. So nitrogen can be provided in the form of ammonia, nitrates, urea, etc. And phosphates is also required, but this is not a critical parameter. But carbon and nitrogen is very, very critical for the growth of the organism. So coming to the cycle, I will show you here directly. So this is the fermentation. So organism is taken in a fermenter and fermentation is carried about. So during the fermentation, the organism will utilize the calcium hydroxide. Okay, so calcium hydroxide is introduced within the system, and then organism is introduced, and other growth requiring parameters like carbon source, nitrogen source, all that is introduced. So now what it converts that calcium hydroxide. So once that is converted, it produces various products. So once it is producing, it tries to produce citric acid. This fermentation broth is completely heated, and once it is heated, so heating conditions, you can see there it is 70 degrees centigrade for 15 minutes, so that various proteins present in the samples are coagulated, because we don't want proteins, we are interested in citric acid. So all the proteins present in the system are coagulated by heating. So after that, the pre-treatment of broth is done. So once that is done, this is the pre-treatment step, after which you do the filtration. Because your citric acid is now present in the filtrate, we don't want to require the mycelium. So continuous washing is done, so that whatever citric acid is attached to the mycelium, that has been washed away, so that we recover those citric acid. And then after filtration, you introduce it some amount of lime there. You can see there lime is introduced, and pH about 2.7 to 2.9 is maintained at 70 degrees centigrade. So what happens during this, when lime is introduced, it converts the citrate to calcium to calcium oxalates. So calcium hydroxide was introduced initially, so that is converted to calcium oxalates. So that calcium oxalates is separated. So this is a byproduct which is not of interest, so that is separated from the system. So now you have citrate. Finally, again in the next step, again little amount of lime is added, and the pH is made close to 7, and the temperature is around 95 degrees centigrade. Within this step, you get calcium citrate as precipitate. So calcium citrate is further separated, again washed, so that the waste filtrate is collected out, and then sulfuric acid treatment is done. Okay, the sulfuric acid that is used is around 0.1 to 0.2 normal. Okay, so once sulfuric acid treatment is done, the gypsum is formed in this process, and again you can use a separation technique. So everywhere wherever separation is written, you can use either filtration or centrifugation. So once you use the separation technique, you get calcium sulfate, that is gypsum. So this is also a byproduct, a waste gypsum, that is calcium sulfate. It can be exploited, even that can be used as the raw material for other industries like cement industries, because gypsum has got calcium, the cementitious properties. So you can be exploited there, and further purification is done using activated carbon or ion exchange resins. So after purification, it is passed through a vacuum evaporator system where a temperature around 40 degrees is maintained, so that it does not caramelize, and your product is ready with you, that is citrate, your product of interest. That after evaporation, it is sent to crystallization unit, because we know the importance of crystallization. It is the polishing technique. So finally you want citric acid in the form of powder. So that is why they are sending it to crystallization unit, and after crystallization you want to separate the solids. So again a separation or centrifugation system is used to separate the solids from the liquid, and the mother liquor is recycled back, because it can be further used to see if any of the crystal is remaining within the liquor, that can be recycled back. So it is recycled back and again given for sulfuric acid treatment to recover. Even if a minute quantity of citric acid is there in the system, they want to recover everything of it. So that is why the mother liquor is sent back and recovered again, and then finally you send it to the drying system or packaging system. So this is how the downstream processing of citric acid is carried about from your organism, that is Aspergillus niger, by fermentation process. And further steps we have seen, like how they try to recover the products, how byproducts are removed, and finally you have the polishing steps done, that is crystallization and drying, to get the powder, the citric acid powder, ready for you, which can be packaged and marketed. Okay, so for production of 1 ton of citric acid, so if you want to produce 1 ton of citric acid, you require 579 kgs of calcium hydroxide, 765 kgs of sulfuric acid, and 18 meter cube of water. Okay, so this is like a thumb rule. So much of the other raw materials are required, and it will result in 1 ton of gypsum. You can see if you want to produce 1 ton of citric acid, approximately same amount of gypsum is produced. So this can be exploited. So this gypsum can be sent to cement industry, and then you can exploit that. You can make the company can make profit out of the byproducts also. Apart from citric acid as a product, they can sell gypsum as a product, which can be given to cement industry. So this is the DPT steps for production of citric acid. So the same explanation have been highlighted in the slides. You can just have a look whenever you want. Okay, the same thing have been highlighted here. That is your recovery process of removing each component in the system and then treating it with sulfuric acid. Okay, and then using activated carbon system and using vacuum evaporators for drying the system, and then further using crystallization, centrifugation. The next product that we have is vitamin B12. Okay, vitamin B12 is also called as cobalamin. Cobalamin, it is a water soluble vitamin which is very much essential for the normal functioning of your brain and nervous system. So if you want your brain and nervous system to function properly, you should have a good amount of vitamin B12 in your diet. Okay, so organisms again are exploited here for production of vitamin B12, and Propionibacterium denitrificans, okay, denitrificans are the common organisms which are commonly used. Okay, these organisms are highly exploited for the production of vitamin B12. Okay, so a lot of strain improvement studies have been happened, and because of which vitamin B12 can be produced in very high yield. Okay, yield of this particular organism for the production of vitamin B12 has been exploited. Okay, so here also some essential elements like cobalt and other elements like 5,6-dimethyl benzimidazole, glycine, all these are required for the organisms for their growth within the system. Okay, so vitamin B12 helps in the production of healthy RBCs. Okay, so for your RBCs to function properly, to produce good quality of RBCs, vitamin B12 is highly essential. Hence, if people do not have vitamin B12 properly, then it leads to anemic conditions. So that is a problem. So that is why vitamin B12 is very, very important. Apart from that, vitamin B12 has got wide applications in food industry. It can be used as a cofactor, as well it does have a wide application in medicinal industries. Okay, as a medicine. So coming to the downstream processing of this product, so denitrificants, as I told you, that is particularly used. So the broth containing this particular organism is heated to 30 degree at 120 degrees Celsius for 30 minutes. Okay, so once you heat it at 30 minutes at 120 degree, then it is cooled. Okay, the system is cooled, the broth containing the organism and the sample within it is cooled, so that, and the pH is adjusted to 8.5, after which potassium cyanide is added to this is added because it forms cyanocobalamin. Okay, to form cyanocobalamin, potassium cyanide is added, and it is agitated for 16 hours at 25 degrees centigrade. After which small amount of zinc chloride is added, again pH adjustment is done, and finally filter aids are added because we want to separate the organism from your filtrate, because your filtrate is having your product. Okay, so that is why to aid the filtration process, filter aids are added, and once filter aid is added, definitely your filtering rate is going to increase. That is how your filtrate is collected. Once your filtrate is collected, they are doing a lot of extraction process. Okay, various stages of extraction is carried about. So they use cresol and carbon tetrachloride. These are organic solvents. So they're using this 3 times. Okay, 3 times this system is used in the ratio 1:2. Okay, so cresol and carbon tetrachloride mixture is used in the ratio 1:2, and that has been used 3 times for extraction. So you will get the organic extract 1, 2, 3 like that. So after you do it 3 times, then you add some quantity of N-butanol and extract 3 times with water. So now once you do 3 times extraction with organic solvent, next time again they do 3 times extraction with water. So once you do this, you get aqueous extract of your product. So with each step of this, you're trying to enrich your product. So these are enrichment steps. So once you enrich this, again you do the organic solvent extraction, the same cresol and carbon tetrachloride in the ratio 1:2 is used. Okay, and then you further extract it. But you can see here they have used only 30 ml. Previously they had used 350 ml. So by each step you are trying to reduce your volume. So finally you are trying to reduce your volume of sample. Okay, that means you're concentrating your product. So by enrichment technique, you're trying to make your final product concentrated. So after this, you will get organic extract again. So after which you are adding small amount of acetone and ether. So after this step, you get something called as crude vitamin B12. It is a crude product, that is vitamin B12 in the crude form. Okay. Finally, they dissolve it in methanol. Okay, to make it solubilize, they dissolve it in methanol and they pass it through a chromatographic column containing activated alumina. So this is further purification of your sample. Okay. So further purification is done using chromatographic techniques, and final elution is done with 2% acetic acid in methanol. Okay. So final elution is done using methanol, and then finally your sample, that is your vitamin B12 in the pure form, is precipitated with ether. So once it is precipitated with ether, you get the purest form of vitamin B12. Okay, so this can be finally dried and it can be packaged and it can be used for the application. So either you want to give it for your medicinal applications or you want to give it for some cofactor applications. Based on where you want to give it, the product is ready now. It can be packaged and marketed. So the same thing I've explained here. So the whole broth is heated initially. Then it is conversion of cobalamin to cyanocobalamin by treating it with potassium cyanide. And then addition of filter aids to remove the impurities and to aid filtration. Then multiple steps of enrichment where you try to use organic solvent for extraction. And finally you use chromatographic technique for separation. And finally you do the ether precipitation. Okay, so after this precipitation with ether, you get pure vitamin B12, which can be finally sent to the polishing unit, that is for drying, so that it can be packaged to avoid fungal contaminations, and apart from that to increase the shelf life of the product, and finally that can be marketed. Thank you for watching guys. Do subscribe the channel for more updates.